Okay, welcome to Code for Fun for Secondary School. Okay, I am Xiang, and I will be your trainer for today. Okay, I will be sharing with you on the topic of computational thinking. So, firstly, what is computational thinking? Okay, it's not thinking like computers. Okay, so this is something that we want to get that clear first. Okay, rather it is a problem-solving technique that help you to solve problem. Okay, so can you think of times when you have a problem and you're not too sure how to actually approach a problem? So what computational thinking can help you is to teach you how to think about problem so that it's easier for you to solve it. Some examples that you may already be using computational thinking are, for example, planning the faster route to school, or how to plan a project, or how to create a list of steps for a recipe. Okay, so this slide, I will share with you, what does actually computational thinking consist of. Okay, so there are 4 steps. Number 1, decomposition. So what is decomposition? It is about breaking complex problem into similar or manageable sub-problems. So in summary, think of decomposition as breaking things down into simpler parts. Okay, next, pattern recognition. Okay, so pattern recognition is about looking for similarity in your problem. Okay, next, abstraction. Okay, abstraction is about focusing only on the relevant details that can affect the problem. It is about looking for the relevant things. Okay, next, algorithm thinking. Okay, so what is algorithm thinking about? It is about looking at sequence or steps, to solve the problem. Okay, so far, does this sound complicated to you? Okay, not to worry. Okay, we are going to talk about each of them in the next few slides. Then that can help you understand the 4 steps better. Okay, so right now we are going to talk about decomposition. Okay, so decomposition, as I shared with you just now, is about breaking down problems into smaller parts. So example is about eating a burger, So, a burger is usually quite big, bigger than our mouth, right? So would you want to eat a burger, or would you be able to eat a burger, in one mouthful, just like Scooby-Doo in the cartoon? Or would you need to eat the burger in small mouthful? In other words, eat it in a small mouthful, step by step, in that to finish the whole burger. Okay. So I think the answer is quite obvious, right? You will actually eat the burger as small mouthful. Okay. Another example, can you as another example on the screen here, you can see how would you memorize this string of numbers? So at first glance it looks very complicated, right? But however, if you look at it carefully, right, you can actually decompose this string into simpler parts. Okay. Do you realize that the first part is actually 5, 4, 3, 2, 1, followed by 8, 7, 6, 5, 4, then followed by 5, 4, 6. Okay, so by decomposing into 3 parts, it became easier for you to memorize. Okay, so far? Is this something that you find easier? If you find that it's actually easier if you decompose the problem into smaller parts? Yeah. Okay. So next. Okay, so before that, so all the above are done by breaking down the problem into smaller parts, and then after that, we do realize that, it became easier to solve. Okay. Yeah, so this is a cute picture of Scooby-Doo eating a burger in one mouthful, which is something that we can't do. Yeah, we need to break it up. We need to eat it in multiple mouthful. Okay, next, pattern recognition. So what is pattern recognition? Okay, it is about finding similarity among objects or situation. Okay, so over here you see a diagram. Okay, so the question to you: what do these items have in common? Okay, so do you realize that they all can spin and they all have round shapes? Yeah, so you do actually recognize a pattern, in these six objects. Okay, so another one. This is slightly more difficult. Okay, so the question is the same. What do these items have in common? Okay, can anybody find a pattern in these 6 objects? Okay, so give you some hint. It is about the way it is spelled. Okay, so the first one is won't, second one is bowl, and third is boat, followed by ball, book, and boots. You realize that all of them start with the letter B. Yeah, so this is the pattern. So basically this is the pattern for this for these 6 objects. Okay. So yeah, so as you can see from the slide here, it's about finding similarities among objects. Okay. And sometimes it may not be as obvious, just like the second diagram. However, when you discover the pattern, it became a lot easier. Yeah, it became a lot easier to solve the problem. Okay, next is abstraction. Okay, so what is abstraction? It is about focusing on the necessary detail and taking out parts that do not matter. Okay, so over on this slide itself, you can see that there are 6 animals. Okay, 6 cute animals. Okay, so the question to you, to understand what is abstraction. Okay, so the question is, which detail do we focus on to figure out which animal can fly? Okay, I have 4 options for you. Okay, do we focus on the skin color? Do we focus on the number of legs? Do we focus on the presence of wings? Or do we focus on the presence of a tail? Okay, so again, the question is, which detail do we focus on to figure out which animal can fly? Okay, so if your answer is C, you got it right. It's the presence of wings. So you realize that, skin color, the number of legs, and the presence of a tail, do not help us figure out which animal can fly. These are not necessary detail. Okay, so far? Okay, then we move on to the next computational thinking. Next step in computational thinking. Okay, that is algorithmic thinking. Okay, algorithm thinking. Okay. Okay, so what is algorithm thinking? Okay, so to help us understand, let's think of okay, let me explain what is actually this about. Okay, it is about using a sequence of steps, which is algorithm, to solve problems. Okay. So for example, think cooking, this is a very a good example, cooking. So what do you need to do to cook? Okay, so can anybody think of maybe when you get the chance to cook, or when you see your mother cooking, what do they need to do? Okay, they need to follow a series of steps. Okay, such as measuring ingredient. You need to put in the right amount of ingredient to cook. Let's say for example, you want to bake a cake. You need to put in the right amount of flour. You cannot put it too little or too much. You cannot put too much sugar, otherwise it becomes too sweet. If you put too little sugar, you will not have enough sugar and you won't be sweet enough. Okay, so yeah, measuring ingredients. Okay, chopping vegetables, cooking them in a certain way. Okay, following the steps precisely can result in a delicious meal. But if you don't follow the step, deviate from the process, it will lead to a less desirable outcome. Okay, so algorithmic, sorry. So yeah, so algorithmic thinking is about, it's the process of developing a step-by-step solution, to the problem. Okay. Okay, so yep. Okay, so that led us to this summary page. So just now we went through 4 steps, in computational thinking. Decomposition is about breaking things down, a problem, into smaller parts. Okay, pattern recognition, finding things that are similar or almost similar in different objects. Okay, abstraction, process of taking out details that don't matter and focus on the details that do. Okay. Okay, algorithm thinking is a step-by-step solution to solve a problem in the real world so the key is step-by-step. Knowing the process, understanding the process, and following the process step-by-step. Okay? Okay, so that's all for my presentation on computational thinking. Thank you for your time.